Discrete math for talented class and ICT class, and evolutionary computation for computer science students. Normally for third year and fourth year students. And here's my research: artificial intelligence, algorithm, and optimization, computational intelligence, evolutionary and multitasking. And we are interested in evolutionary computing for solving optimization problems, such as distributed system, coverage problem in wireless sensor network, maximizing the lifetime of wireless sensor network, and resources provisioning in mobile edge computing network. And you have to complete the midterm exam and final exam to get the result of this course. In the talented class, I usually provide a project for students to complete, and they will get the result for midterm exam. But for ICT class, I know that there are 67 students in your class, so I'm thinking if I could provide project for you. Later, I will introduce all the project, and we will discuss among your class if you would like to do project. You would like to do the midterm exam. And the topic for this course, combinatoric and graph theories. In combinatoric topic, we'll go and consider for 4 problems: counting, enumerating, assisting, and optimizing problem. And in graph theory, we'll study definition of graphs, tree, and paths. And here are some of my research projects. The first one, I'm collaborating with Dr. Nguyễn Phi Lê in software engineering department. We are using AI-based mobile air quality monitoring and forecasting system. And this project funded by Vingroup Innovation Foundation. And the project funded from 2020 until 2022. And the second one is the project funded by National Foundation of Science and Technology. And we are using nature-inspired algorithm for maximizing lifetime of wireless sensor network. And the third one is funded by U.S. Army Research Lab and U.S. Army International Research Center. And we are using multitasking evolutionary algorithm for optimizing artificial neural network and graph-based model. And the project started on 2019 and will be finished on 2022. And the last one already finished, but we still continue this research direction and developing meta-heuristic technique for solving optimization problem in distributed and software system. And the objective of this course to learn the mathematical concept and graph, and to improve the problem solving skill, to know the connection between discrete math and computer science, and to learn how to join the project and working team. Yeah. That's all of my introduction about. Yeah. Later, I plan to introduce about my research project. Do you have any question? Do you have any question?
Không ạ.
If you do not have a question, next I will introduce about my research topic. Yeah, as you know, my research includes in computational intelligence, magnetic computing, multitask learning, transfer learning, and reinforcement learning. And computational intelligence, magnetic computing, and multitask learning, transfer learning, and reinforcement learning is belong to evolutionary computing. And evolutionary computing has a lot of application in vehicle and transportation system, in cybersecurity, in data mining, and engineering solution, image and pattern recognition, and in a lot of renewal application. And so that is the main of my research. And here's some award and recognition related to this research topic. On 2021, this year, my team won the first prize in the competition on evolutionary multitask optimization, multitask single objective optimization at IEEE Congress on Evolutionary Computation. This is the top tier conference in the field of evolutionary computation. And last year, we won the second prize in the competition on evolutionary multitask optimization, multitask single objective optimization at IEEE World Congress on Computational Intelligence. And 2 years ago, last year, we won the third prize in the competition on electric vehicle routing program at IEEE World Congress on Computational Intelligence. And 2 years ago, we won the first prize on multitask single objective optimization competition on evolutionary multitask optimization at IEEE World Congress on Computational Intelligence. We call WCCI means that's the IEEE World Congress on Computational Intelligence. That's the biggest congress or biggest conference in the field of computational intelligence. And it will be held once per 2 years. And there are around 3,000 to 4,000 people participate in this congress. And based on the review of mathematics, I'm one of the 8 authors in the world who contribute in the multitask optimization and multitask evolutionary computation in the past 5 years. Past 5 years means that from 2017 to 2021, in this field with the multitask optimization. And here are some research topics we are doing. I plan to give this research topic for you if you are interested in. There are 2 options for you. The first option, this is optional. If someone who are interested in this topic, so please contact me. We will work on this topic, and at the end of this semester, you will give presentation. And I plan to plus 3 points in the final examination. And the other option, so you need to discuss among all of colleagues in your class. If all of you are agree, so you will divide to some group maybe 67 students will be divided to 13 or 14 group, and we'll do this research topic, and you will give presentation at the end of this semester, and then you will get the midterm examination. How to do the research project? I will conduct 2-hour lecture, theory lecture for you on today, and but on the other day of the week, I will work with on your research group on different days from Monday to Sunday. I will make schedule for different group, and maybe you will work with us, with me and with my PhD student and with my master student, and third year and fourth year student. They will guide you how to join research project, how to work with team, and how to apply the algorithm, the knowledge of discrete math for solving some optimization problem. And next, I will introduce one by one for the research topic, and you will decide later for me, maybe next week, we discuss how to organize group for the research project. I repeat again, the first one, the first option. So that is the optional. If someone who are interested in this topic, so please contact me. The second one is if all of you are okay to do research project, and then we define the research topic for all of you, maybe around 14 to 15 group, and then we will work together with my PhD student, master, and third year and fourth year. We will send the schedule later based on your schedule and based on the research topic. Yeah. Next, I would like to introduce the first topic is the evolutionary algorithm for neural network. And neural network a class of machine learning algorithm, and we need to learn to solve a task from the existing data. And here's an example of neural network. You have input and output, and between input layer and output layer, you will have a hidden layer, and you need to apply some algorithm to solve optimization problem in neural network. And they have a large application in computer vision, in natural language processing, and reinforcement learning. And in this project, we are interested in multi-objective reinforcement learning. And what is the reinforcement learning? We have to teach agents to learn and perform in an environment. And in multi-objective, agent need to balance between multiple objectives that need to be achieved. Multi-objective, for example, you want to buy a car with of course you want to buy a car with the cheapest price, but highest quality. But if the car has a high quality, so it's difficult for you to buy with a cheap price. Normally, a high quality has the car with high quality normally expensive. So it's difficult for you to get the balance between the price and the quality of the car. So multi-objective optimization problem, it means that you have to solve and you have to find the solution for to get balance between 2 or 3 or 4 objectives For example, the price of the car and the quality of the car. If you want to buy BMW car, so now it's more expensive than the other car in, for example, Hyundai or Yaris or some other. So it's difficult for you to get the balance. So here we have to solve the multi-objective reinforcement learning. And we are also interested in reinforcement learning for combinatorial optimization. Search for an optimal solution from finished stage to short space. And what is the problem? Short space is too big, so issue is the exhaustive search not efficient, and we have to solve the optimization problem here. And we also apply evolutionary algorithm to optimize neural network and optimize neural network parameter in the neural network. We use evolutionary algorithm to optimize parameter inside a small neural network and optimize neural network hyperparameter. We use the evolutionary algorithm to optimize hyperparameter, for example, number of layers, number of neurons inside neural network, and we are solving neuron architecture search, and here need to search for an optimal architecture of neural network for specific problem.
Em thưa cô ạ.
Yes.
Em thưa cô là bọn em cũng nhìn slide của cô từ nãy giờ rồi ạ.
Thế sao em không nói?
Vừa nãy em bật mic nói nhưng mà cô nói dạ lâu quá nên chắc cô không nghe thấy ạ.
Thế thì bọn em không nghe thấy slide từ lúc nào?
Từ lúc mà có cái contact của cô ở trên ấy ạ, có cái information là bắt đầu bọn em không thấy được nữa rồi ạ.
Thế à? Thế thì bây giờ cô lại phải tua lại từ đầu à?
Dạ.
Thế sao cả lớp bọn em cứ ngồi yên thế?
Nhưng mà em không biết tại sao, chắc là một số máy vẫn để hình slide information của cô ấy, thì em vẫn đang tưởng là cô vẫn đang giới thiệu chưa vào bài mới thôi.
Thế bọn em có nghe thấy cô nói không?
Đã có ạ. Hay cô nói bằng tiếng Việt đi cô.
Nhưng mà không được, bởi vì là môn dạy bằng tiếng Anh thì không được nói bằng tiếng Việt. Thế thì nếu mà trong lúc mình nói mà nếu có vấn đề gì bọn em phải nói ngay. Từ nãy tới giờ cô đi được bao nhiêu slide rồi? Hôm nay cô có hơn slide bài giảng là 100 cái slide và rồi slide giới thiệu cô lại vài chục cái slide. Nghĩa là từ nãy đến giờ cô đi rất nhiều rồi.
Tại vì có mấy bạn bảo là vẫn còn xem được slide nên là em tưởng máy em lỗi cô ạ.
Thế. Có bạn nào bạn ấy chụp cái ảnh này?
Chắc lúc đấy máy bị treo cô ạ, thế là nó cứ ghim lại cái hình ảnh đấy, thì là em không biết được. Thôi cô cứ giảng lại bằng tiếng Việt đi cho dễ hiểu cô ạ.
Thế em có nhìn thấy slide không? Em có nhìn thấy slide di chuyển không?
Dạ, bọn em nhìn thấy rồi.
Thế thì những chỗ này là giới thiệu về cô thì bọn em rõ rồi đúng không? Thì thôi cô bỏ qua cái slide này nhé. Thế ban nãy bọn em có nhìn thấy cô di chuyển đến slide này không?
Dạ có cô ạ.
Có rồi.
Tức là cái bộ slide này là xong rồi, chỉ khi sang cái bộ slide. Thế có nhìn thấy cái slide này không? Cô chuyển sang slide khác rồi.
Không
Dạ,
ạ.
Không phải ạ.
Rồi, ok. Nhìn thấy chưa? Nhìn thấy slide mới chưa?
Rồi.
Chắc là ban đấy nó bị treo từ cái trước. Ôi giời.
Sao đâu cô?
Thì nói xong giờ lại tua lại, bởi vì từ đấy giờ đi đến một chục cái slide rồi thì bọn em không nhìn thấy hình chứ sao?
Thôi nói tiếng Việt sẽ hiểu hơn cô ạ.
Bây giờ lại tua lại slide à? Cái phần này là đang nói về các nghiên cứu của mình. Nghiên cứu của mình thì về computational intelligence, mermatic computing, multitask learning, transfer learning and reinforcement learning. Là những cái này thì tất cả những nghiên cứu của mình thì đều liên quan về thuật toán, và mình làm về tính toán tiến hóa. Tức là cái buổi đầu hôm nay là để kiểu cô trò giới thiệu ấy, thì mình giới thiệu về mình giới thiệu về nghiên cứu của mình, em hiểu không? Thế thì cái tính toán tiến hóa này nó có ứng dụng rất là nhiều trong cuộc sống. Nó có ứng dụng ở trong cyber security, trong data mining, trong pattern and recognition, trong rất là nhiều các lĩnh vực. Thì năm nay thì nhóm của mình đã giành được giải nhất tại cái competition evolutionary multitask optimization, multitask single objective optimization tại IT3022E Congress on Evolutionary Computation. Thì đây là một cái hội nghị đầu ngành về Evolutionary Computation. Năm ngoái thì nhóm mình có giành giải nhì second prize ở competition on Evolutionary Multitask Optimization. Tức là mình làm về multitask optimization, multitask single objective optimization tại IT3022E Congress on Computational Intelligence. Thì cái hội thảo này nó là cái đầu ngành về Computational Intelligence, và họ tổ chức 2 năm một lần. Mỗi một lần hội nghị thì họ có vài nghìn người đến dự. Còn năm ngoái thì nhóm mình cũng đề xuất ra các thuật toán để giảm cái bài toán tối ưu lập lịch cho xe điện ở một cái cuộc thi về tối ưu lập lịch cho xe điện, thì cũng được giải ba ở cái WCCI năm 2020. Và 3 năm trước vì WCCI thì chỉ tổ chức vào năm chẵn thôi, thì 3 năm chẵn thì nhóm mình cũng được giải nhất ở cuộc thi là Multitask Single Objective Optimization. Trong đầu năm nay thì ở trên tạp chí Mathematics họ đã có một cái bài review về những cái tác giả, tức là những cái nhà khoa học mà trên thế giới có đóng góp trong cái lĩnh vực, có đóng góp hoặc là có ảnh hưởng trong cái lĩnh vực về multitask optimization. Thì có danh sách họ có show ra có 8 người thì là cũng có đóng góp rất là nhiều về các kết quả nghiên cứu trong cái lĩnh vực là multitask optimization. Thì đây là các cái research topic mà nhóm mình nghiên cứu và mình cũng dự định cho sinh viên làm. Thì có hai cái lựa chọn cho bọn em. Một cái lựa chọn thứ nhất là ai thích thì liên hệ với mình thì làm. Nếu mà làm thì sẽ ngoài cái buổi học 2 tiết lý thuyết ở trên lớp này thì sẽ join vào cái nhóm của mình. Thì có 8 cái hướng này, thì mỗi một nhóm là một buổi khác nhau. Thì tức là bọn mình sẽ hướng dẫn các sinh viên mới sẽ phải học về thuật toán, sau đó sẽ áp dụng các thuật toán đó để giải các cái bài toán này. Đấy là option thứ nhất. Option thứ hai là bọn em thích thì cả lớp bọn em mà đồng ý thì bọn em sẽ chia nhóm, sau đó là gắn vào các cái project này, xong bọn mình sẽ hướng dẫn các nhóm này làm. Thì cuối kỳ bọn em báo cáo thì có thể là mình sẽ tính điểm giữa kỳ, còn nếu cái option 1 thì sẽ là chỉ cộng điểm cho những bạn nào quan tâm. Thì cái đấy bọn em cứ tự trao đổi trong lớp, một tuần sau bọn em trả lời lại cho mình. Thế nhưng mà làm sao để có thể bọn em trao đổi và bọn em đưa ra được quyết định vào tuần sau, thì Thì hôm nay mình sẽ phải giới thiệu nhanh qua về các cái topic này để các em biết nó là gì. Tất cả các topic này thì đều phải áp dụng các cái thuật toán hoặc là các cái kỹ thuật mà học ở trong phần toán rời rạc hoặc là trong các phần nâng cao để giải nữa. Đấy. Thì coi như là để áp dụng để giải các bài này luôn. Thì cái phần đầu tiên là áp dụng các thuật toán tiến hóa để giải các bài toán trong mạng neuron. Thì bạn thấy mình nói qua hết cái này rồi trong mạng neuron. Đây thì bọn mình có quan tâm đến cái phần là multi-objective reinforcement learning này, reinforcement learning cho các bài toán tổ hợp. Đấy. Và neural architecture search thì đây là những cái vấn đề mà cần quan tâm, tức là tất cả đều xoay quanh về optimization problem. Thì đấy là cái topic thứ nhất. Next, I would like to introduce about multi-domain network optimization. That's the second one research topic for you to consider if you are interested in, and then you can contact with our research group. We work together for solving this problem. And what is the multi-domain network? It has a lot of application in computer network, in the software-defined network, and in military communication, in phrase crafting. For example, there are rail track, air track, and sea track, and road track. You have to go from the starting point to the destination point. You can use several domain, each domain corresponding to one track. For example, rail track domain and air track domain or road track domain. And you can see the rail track, and as the interconnection point, you can change the transportation, and you can use road track, and another interconnection point you can change. You use air track. For example, you can use the several domain for the transportation, and then you will reach the destination. So the question is how to make routing for you and how to make the schedule for you, so that minimize the traveling time, or minimize the distance for you, or minimize the cost for you to have to pay for this traveling. Yeah. And here we focus on finding the routing problem in multi-domain network. I noticed that this problem is related to all the definition of the graph in the mathematics subject, and the spanning tree, and the minimum spanning tree, and the path in the graph theory in this lecture. And point to point, we are interested in the interdomain path computation under the domain uniqueness constraint, and point to multi-point. We can call that multicast, and we are solving by applying cluster Steiner tree problem. And our approach, we propose evolutionary and swarm intelligence algorithm, heuristic and meta-heuristic, for solving this kind of problem. And as you can see, multitasking optimization problem is different with single task optimization. In multitasking optimization problem, you will solve multiple optimization problem at the same time, and facilitate knowledge transfer between problem, and give better solutions than the traditional approach. For example, in sequential optimization, you will solve one by one task, but at multitask optimization, you have to solve several tasks at the same time. So you propose to unify search space, or we can call knowledge base, and you must all the knowledge of the first task, the second task, and the K task, and we call that multitask evolutionary algorithm. So we propose multitask evolutionary algorithm for solving this kind of the problem, so that you can inherit a good gen from the first task and the second task or the other task, and you can inherit the good gen from the first step to transfer to the next step. So we hope that we can find the better solution than the traditional approach. Yeah. The first problem is the charging schedule for optimization in wireless rechargeable sensor network. I think all of you already know what is a wireless sensor network. But there are some challenges in wireless sensor network. Network coverage, network connectivity, network security, and energy issue. For network coverage, the problem is how to fix the sensor so that all the target in the area will be covered by at least one sensor. So the problem we call network coverage. The network connectivity is we have to put and fix the sensor on the place so that if one sensor die, the network will be disconnected. But in this case, if the network will be connected, so you cannot get the data from the network. So you have to design the network, wireless sensor network, so that if one sensor is dying, the network still working, so you will get the data in the network. So the problem is the network connectivity, and the third one is the network security, and the last one is the energy issue. And in this problem, we are interested in the energy issue because sensor node has a limited battery capacity. So if the battery if runs out battery, so the sensor node will be dying. So the wireless sensor network will be disconnected. So how to maximize the lifetime of battery is one of the issue in the wireless sensor network. And here's one example of wireless rechargeable sensor network. In the recently, there is a new technology we call wireless rechargeable sensor network. It's different with wireless sensor network. You already know. In wireless rechargeable sensor network, there is a mobile charger. There is the car or mobile in this picture, and one base station, and some sensor node in the green color and service station. And the question is how to make the schedule for the mobile charger to go around the wireless sensor network to provide the energy for the sensor, to avoid the run out of energy for each node of sensor. And wireless rechargeable sensor network has a lot of application in smart agriculture, in environment monitoring, in smart city. And a charging scheme is comprised of two principal factors, and including charging path and charging time. What is the charging path? Charging path is a sequence of charging location sorted by the visiting order of mobile charger. And charging time is the time duration that mobile charger stay at each charging location to charge the sensor. And the challenge is here, how to design the effective charging scheme to avoid energy depletion of sensors, and how to schedule the charging path of the mobile charger to obtain the highest charging efficiency, and how much of the charging duration at each charger H visited sensor. And here's the classification of charging scheme. Yeah. And some issue related to mobile charge, multiple mobile charger, and point-to-point charging, or point-to-multiple charging, or periodic charging, or full charging, or partial charging. And we divide it to some problem. And the first one is the single charger, single point model. And we have only one mobile charger, and we need to make the schedule for the mobile charger to go to sensor node to provide the energy for the sensor node. And the input is a base station, a list of rechargeable sensor and mobile charger consumption energy rate and residual energy of on sensor. And the output of the problem is you have to make the charging path of the mobile charger and the charging time at each sensor. The objective of this program is minimize the number of dead nodes. Here is the single charger, single point model. And another problem is the single charger multi-point model. In this program, we have one mobile charger, one base station, and we have some rectangular. The mobile charger will come to the triangle, and at this point, at a red point, you can provide energy for some sensor near it. For example, for 2 circles around the red triangle. And so this problem we call multi-point model. And the output is the charging location and the charging path of the mobile charger and the charging time at each sensor. We need to find the charging location, the red triangle, for the mobile charger come here and provide energy for 2 or 3 sensors around the triangle. And another problem is the multi-charger single point model. It can be applied for the large-scale wireless sensor network. And in the large-scale wireless sensor network, we cluster all the sensor in some small group. For example, in this picture, we divide all the wireless sensor into 3 cluster, 3 groups, and then we apply each small group as the previous program settlement. Yeah. So here we have 3 mobile charger and 3 cluster. And yes.
What is the dead node?
The dead node is the if the node runs out of the energy, so we call the dead node.
Okay, thank you, sir.
Yeah. If one sensor runs out of the energy, so that sensor will be dying. So that the wireless sensor network will be disconnected. So in this kind of the problem, we have to solve the problem that we need to provide the energy for all the sensor nodes, so that it cannot be dead because if it's dying, so the wireless sensor network will be disconnected. But it's difficult for only one mobile charger provide energy for all the sensor nodes at the same time, and the time for the energy and the timing of each sensor is different. So we need to predict which sensor node and how to provide energy for all the sensor nodes. Yeah. So that is the optimization problem. And another problem related to wireless sensor network, we call area coverage problem. Here we are interested in the target coverage and connectivity fault tolerance in wireless sensor network, and target coverage and connectivity with multiple mobile SIMs, and connectivity with multiple mobile SIM in mobile sensor network. What is the target coverage and connectivity fault tolerance? For example, you have one base station, and some targets you need to put the sensor on the place so that each target will be covered by at least one sensor. Yeah. But these sensors are disconnected, so it can be it cannot be connected to the base station. So you have to put more sensor to connect to the base station. But in this picture, if one sensor dies, so the network also will be disconnected. So the problem here, you have to make the how to put on the sensor, how to put the sensor, and how many sensor do you need to put so that the wireless sensor network will be still working in all the time. For example, you have to put more sensor here, just put or two more sensor. In this case, you can find two paths from one sensor to another sensor. If you always can find two paths from one to another, so in this case, if one sensor dies, you can find another way from that sensor to another. So we call that the target coverage and connectivity fault tolerance in wireless sensor network in this problem. Do you understand? So here it relates to combinatoric problem, optimization problem, and it also relates to the graph theory problem in the discrete math. The problem is how to put the sensor where to put the sensor and how many sensor do you need, and of course you need to minimize the number of sensors to save the cost for you, and how to put the sensor so that ensure the connectivity in the wireless sensor network. Even the picture is very simple, but there are a lot of questions and optimization problem in this picture. In this picture, we will use a mobile SIM. It can be moved to another place to provide energy for the sensor network. So we do not need to connect to the base station. For example, you have two mobile SIM, so it can be moved. So the question is how many sensors do you need? Where do we need to put the sensor so that all the target will be covered by at least one sensor and ensure the connectivity of all the sensors. And another problem is the connectivity with multiple mobile SIM in mobile wireless sensor network. The car will be moved on the road, yeah, and you need to put the sensor so that the car always connect to the base station. So you can keep the car or the bus or always connect to the base station and communicate with the agency or get the information the base station. And another topic is the barrier coverage in wireless sensor network. You can see that this the area around the border. This problem has application in the military. So how to put the sensor so that if the intruder go across the border, he or she always can be detected by the camera or by the sensor. Yeah. So you have to put the sensor so that it cannot find any gap for the intruder go across the border. That is the first problem. Is on the left picture, but on the right picture, you have to evaluate wireless sensor network. So if you can find the path for the intruder go across the border, so that he or she cannot be detected by any sensor or any camera. So the wireless sensor network in this case is not good. So we have to evaluate the barrier coverage in this program. But in some program, they have to build a K barrier. In this case, it's the two barrier. The first round for sensor and the second round. So we call two barrier or K barrier. And another topic is the path planning for drone and its application in the transportation program. Yeah, you already know the application of drone. In drone has a lot of application in smart agriculture, in monitoring, and but there are some issues in drone program that they has a limited flight range or specific of motion or specific of information processing and connectivity or limited payload, for example. And we need to solve some optimization problem in routing program with drone combined with truck and truck or vehicle to pick up something to deliver to the customer. Yeah. Recently, our research group are interested in door-to-door sampling to take the test for COVID. Yeah. We have a laboratory and we have some house we call client location. We have some blue color is the drone. So drone will go from laboratory go to the client location to pick up the test and return to the laboratory to take the test, because in this case we don't want to use the technical staff, because if we use a lot of technical staff, so it's not good because due to the COVID. So we want to use the drone to save the time and no need to more the technical staff. Yeah. So here we need to make the schedule to minimize the timing and waiting for taking the COVID test. And another topic is the mobile robot task planning, and it has a lot of application in transportation, logistics, rescue, and army. And the challenge is how to reduce the energy consumption and prolong the life of mobile robot. Become, yeah. There are two types of environment. The first one is the robot path planning in static environment, and the second one is the robot path planning in dynamic environment. And we have one robot to one target. one robot to multitask it and complete work environment. So here are 3 types of problem for mobile robot task planning. Yeah. And the last one is deep learning for resources management in the cloud for environment optimization. And fog computing is an architecture that uses edge devices to perform a significant amount of computation, storage, and communication locally and route over the internet. And here we need to predict the resources and to make the schedule for all the tasks in the fog and cloud computing. Yeah, that's all of my research topic. So if you are interested, in the research topic, so please contact me. I will show it again. Do you have any question? Can you see the new slide?
Yes.
Yeah. So that's all of my introduction about my research. So if you are interested in the research project and our group, so please contact me. Next, I would like to introduce the outline of this course, Discrete Mathematics. And Discrete Mathematics will deal with separated or discrete sets of objects, and rather than the continuous sets. And discrete math will process with a sequence of individual sets, and rather than the continuously changing process. And here are some kind of problems solved by discrete math. For example, the first question is how many ways are there to select a computer password? You can answer this question by discrete math, particularly by counting problem. Yeah. And what is the probability of winning a lottery? Yeah. Is there a link between two users in a social network? You can answer this question by existing problem. And what is the shortest path between two cities using a transportation system? You can answer this question by graph theory. Yeah. So here are some examples of some kind of problem which can be solved by discrete math. So you can see that this is a kind of question around you, but maybe sometimes you do not know that it's related to discrete math. But all these questions are very familiar. Okay. And you can see that it's not difficult for you to answer it, or you find the solution by discrete math. What is the importance of discrete math? the information is sourced and manipulated by computers in a discrete fashion. And application in many different areas. Discrete math is a gateway to more advanced course. And we need to develop mathematical reasoning skill and emphasize the neurons of mathematics. So that's the importance of discrete math. In this call, I want to let you know the connection between discrete math and renewal application, discrete math and computer science. How to connect between discrete math and computer science. I know that a lot of students are aware of discrete math because the students think that it's very difficult for the mathematics, but I want to let you know that it's not difficult for you because a lot of renewal application optimization problem, you can find solution or you can answer by discrete math, and it's very familiar for you. And the goal of this course and to study standard facts of discrete math and develop a mathematical reasoning skill, and emphasis on modeling logic and efficiency. And when discuss application, for example, I already introduced each research topic for you, so you can find the application in this research topic, and later we discuss application. And here's the textbook you can refer, and you can use for reference for this course. The first chapter and the second chapter, I think we can go faster because I think you already study in the high school or the first year. Yeah. So this book will be used for this course. You can use another one in Vietnamese. The author is Professor Nguyễn Đức Nghĩa and Nguyễn Tôn Thành. Yeah. It's easy for you to understand because it's in Vietnamese, and it's a very famous book for all the students who study discrete math. And there are two parts in this course. The first one is the combinatorial theory, and the second one is the graph theory. For the first part, combinatorial theory, the first chapter is the counting problem. This is the problem aiming to answer the question: how many ways are there that satisfy the given condition? And the counting method is usually based on the some basic principle and some result to count simple configuration. And counting problems are effectively applied to evaluation tasks, such as calculating the probability of an event, calculating the complexity of an algorithm. So that is the counting problem. And for example, how many ways to arrange 6 people on 6 people for taking the photo? So we can answer this question by counting problem. And the chapter 2 assistance problem. And in the counting problem, configuration assistance is obvious. But in the assistant problem, we need to answer the question: is there a combinatorial configuration that satisfies given property? So we can see the difference between two red color lines in this slide. So that is the key point of difference between counting problem and assistant problem. Yeah. In counting problem, the question is how many ways are there that satisfy the given condition? But in the assistant problem, is there a combinatorial configuration that satisfies given property? So the question is for the counting problem, is the 10 or 21 or 100? The answer is the number. But in chapter 2, the assistant problem, the answer is the yes, there is or no. Yeah, so the answer is a yes or no. And in chapter 3, enumeration problem, and this problem is interested in giving all the configurations that satisfy given condition. But in chapter 4, the combinatorial optimization problem, unlike the enumeration problem, this problem only concerns the best configuration in certain sense. We are interested in only one configuration, the best configuration. And in the optimization problem, each configuration is assigned a numerical value, which is the use value or the cost to construction of the configuration. And the problem is that among the configurations that satisfies the given condition, you have to find the configuration which the maximum or minimum value assigned to it. For example, there are some way for you to go from the Hanoi University of Science and Technology, go to the Center Post Office of Hanoi. The first one, you go to Discrete Street, turn right and go to the interconnection with Buổi Street, and then go straight to the Center Post Office of Hanoi. And the second way, you go to Discrete Street and go across the Hoa Lư and go to Quang Trung Street, and then Trần Hưng Đạo Street, and then turn left to the Hàng Bài Street and go to the Central Post Office, for example. So there are many ways for you to go from Hanoi University of Science and Technology, go to the Central Post Office of Hanoi. And the question is, what is the way with minimum length? What is the way with minimum interconnection? What is the way with minimum traveling time? Yeah. So this kind of problem we call optimization problem. So you have to answer only one configuration, best configuration. Yeah. So do you understand for problem is a combinatorial theory? Do you have any question? Do you have any question? Do you understand? Huh?
Dạ không ạ.
Do you understand or know what is the combinatorial optimization problem or enumeration problem? The difference between counting and assistant problem? Yeah. If it's okay, so we move to graph theory. In the graph theory, we see what is the graph. So the definition of graph: degree sequence, Eulerian graph, or tree, spanning tree, matching, coloring. Yeah. And the question is how to color a map, how to schedule an exam or project, and you can modeling this kind of problem by graph, yeah. And then you will find the solution by using some algorithm in graph theory. And another problem is how to send the data efficiently. Yeah. So you can see that this kind of problem you already see several minutes ago when I introduced about our research topic. It relates to multi-domain, and you can answer the questions that how to send the data efficiently by using the different domain to connect from the one to another. And next we go to the part one, combinatorial theory. Yeah. There are four main problems: counting problem, assistant, enumeration, combinatorial optimization problem. But first we need to discuss the chapter 0. We define the sum definition. I think that you already study in the high school about the set relation. Related to set and relation, we need to know the definition. What is the set operation? The algebra of sets and computer representation of sets, relation and function. And we have already implicitly deal with sets. For example, we have some sets: integer, rational, nature, rings, and we develop more fully the definition of set, property of set, and operation of sets. And a set is an ordered collection of unique objects. And the objects in a set are called elements or members of a set. And a set is a set to contain its element. And we have a notation for set A. Yeah. If X belongs to, if X is an element of set A, and then we denote like this. And if X is not an element of set A, so you can see in the second row, yeah, like we can denote like that. And normally we often denote sets with capitals, and brackets are used to define the set. Yeah. A multiset is a set where you specify the number occurrence of each element, M1 point A1, M2 point A2, for example, and MR point AR is a set where element M1 occurs A1 time, element M2 occurs A2 time, and element MR occurs AR time. And specification of set. A set is defined in extension when you enumerate all the elements. Yeah. And the set builder notation, A is a set, includes all the X element. It's a satisfy some condition like that. And this could be read as all each element such that the condition hold true. Yeah. Here are some well-known sets in math. Yeah. There is a set with no element, and in this case it's called the empty set or null set, and we denote like that. And a set that has one element is called a singleton set. For the last row, the left-hand side is the empty set, but on the right-hand side is the singleton set, and this set contains a set inside. So it's different between two denotations. If there are essentially n distinct elements in a set S, with n is a non-negative integer, we say that S is a finite set and the cardinality of set S is n. And here's the notation. And we have a definition. A set is a finite set if it has a finite number of elements. And a set that is not finite is an infinite set. And let set A be a finite set. The number of different elements in A is called its cardinality and is denoted by A. And another notation commonly used for cardinality of set A are NA. And if A is an infinite set, then we can write like the last row, like the notation is the last row. Here are some example for specification of sets. The first example shows the number element in the set is a 0. In the second example, the number element is a 3. Next, we move to the set operation. Set comparison, Venn diagram, and set operation and partition and cover is the content of set operation. We have two sets, A and B are equal if they contain the same element. And we write A is equal to B. And here are some examples. For the first example, they are equal because a set is unordered. And also in the set, on the second example, two sets are equal because a set of contain unique element. But however, the last example, two sets are not equal. Px and Qx are propositional functions which are true for the same object x, then the sets they define are equal. And here's the example. And there are two sets. The question is A is equal to B. Can you give an answer? What is the answer? A is equal to B. Is it correct?
Yes. Yes. They
Why?
are equal.
Why?
Because the roots of two sets are equal.
What is your name? Sorry?
My name is Trình. Nguyễn Văn Trình.
Yeah. Okay, thank you. Anyone has another answer? Or only you agree with Trình? Yeah, if you are okay, so we'll move to the next. Yeah, it's easy for you to understand. A is said to be a subset of B if and only if every element of A is also an element of B. And the red color line is the denote for subset A is a subset of B. And here's an example. There are 12 elements in the set S and 6 and 4 elements in the set T. The element is a 1, 2, 3, 6, and the element in the set S is a 1, 2, 3, 4, 5, 6, and 7, blah, blah, until 12. Then in this case, T is the subset of the set S. And another definition, if A is the subset of B and A is different with B, then set A is called a proper subset of set B. And here's an example. A is a set with 3 elements, 1, 2, 3, and B is the set with 3 elements, 2, 3, 1, and C is the set with 1 element, 3. Then B is equal to A, and C is the belong to A, and C is belong to B. And another example of set comparison. The first one is a natural number. The second one is a set of integers. The fourth one is a rational number. Yeah, and complex number. the positive integer, is it includes 0? The natural number includes 0, but the positive integer, is it includes 0?
No.
No. Yeah. We can sometimes use E and O to denote the set of even and odd integer respectively. And you can see the two examples. And universal set U contain as a subset on sets relevant to the current task or study, and anything outside the universal set is simply not considered. And the universal set is not something fixed for all time, and we can change it to suit different contexts. And next we move to the Venn diagram. And a set can be represented graphically using a Venn diagram like this picture. And the universal set U is represented by the interior of a rectangle. And the set by region inside the rectangle and element which belong to a given set are placed inside the region representing it. So you can see three regions in this the place, yeah. A, B, C, yeah. And the cover place we denote by U, and the A element belong to U or U, and X element belong to A and belong to U also. And if an element belongs to more than one set in the diagram, the two regions representing the set concerns must overlap, and the element is placed in the overlapping region. And in this way, the picture represents the relationship between the set concerns. Here's an example. Please draw the Venn diagrams that represent three sets. And we have a three set A, B, C. And here's the picture. Draw the Venn diagram for three sets. Do you understand? Set operation. Arithmetic operator can be used on pair of number to give us a new number. And the similarity set operator exists and act on two sets to give us new sets. Union, generalized union, intersection, or generalized intersection, set difference, or set complement. Then, so there are some type of set operation. And given the universe U and A, B belong to U, and the absolute complement of A is U minus A. Yeah. The relative complement of A in B is B minus A. Yeah. So you can see the two pictures. The answer for these two questions is the bow region. Next, we move to the partition and cover. Let E be a collection of subsets and the set M. The collection E will be called a cover of set M. Each element of set M must be an element of at least one of the sets E. And the disjoint cover of cover E of set M is called a partition of set M. And here's an example. We have a set M. There are 4 elements in M set 1, 2, 3, 4. And we have E1 is a 1, 2, and 3, 4. So we call it a partition of set M. But E2 is a 1, 2, 3, and 3, 4 is a not partition of M because you find 2, 3 positions in E2. Power set. The power set of a set A, we denote PA, is the set of all subsets of A. And here are some example power set. Yeah. Let A be set such that the number element of set A is n. And we prove let A be the set A1, A2, and AN. And we can form a subset and A by considering each element AI in turn and either including it or not is a subset. And here's the proof for this theory. Theorem for the number of power set. And that's all of the lesson today. Next week we'll go to the property of set operation and computer representation of set, relation function. And next week we'll go to the counting problem. Yeah. So do you have any question for the lesson today?
Cô ơi,
Yes.
post lại cái slide này lên nhóm Teams được không ạ?
Mình sẽ gửi lại cho bọn em sau nhé.
Vâng ạ. Cô ạ.
Do you have any question? If you do not have a question, so see you next week. Yeah.
Chào cô ạ.
Yeah. Bye bye.
Chào cô. Chào cô ạ.
Chào cô.
Yeah.